Hey gang, welcome back. Remember, the test is tomorrow on Freefall, and we're going through the review questions for Chapter 3, Freefall. We just did number 1 in the last video, and here's number 2, so let's take a look at it right now. Alright, we've got a ball launched at 30 meters per second, so launched means going upwards, 30 meters per second from 50 meters above the ground. So we can think of it as... maybe it's on a platform or something like that. And there's a platform right there. And it's launched upwards. And comes back down. So this distance right here is 50 meters. And our initial velocity equals 30 meters per second. Okay. So our question is, how high does it go? So what we want to find is our delta y. That's what we don't know. Actually, no, we don't. We're not finding the delta y. We want to find the y final, right? Because we're given the initial y. So y initial, that is the actual position, is what? That's 50 meters, right? 50 meters. Our y final, that's what we don't know. We know our initial velocity, that's 30 meters per second. And what is happening at the highest point right there? In terms of velocity, we know that our final velocity at the highest point right here is 0 meters per second. So let's write that in as well. VF equals 0 meters per second. I think that'll come in handy. And also, as is always true, acceleration equals negative 9.81 meters per second squared. Okay. So we're solving for YF because the question is, how high does it go? It doesn't ask you what the displacement is. It actually asks you what the value of the height is. So we want to possibly solve for delta y. Why is that? Because our change in y is our y final minus our y initial. So let's substitute this in for that if we have an equation that has our delta y in it, because ultimately we want to solve for our y final right here. Oh, I think we have an equation that works for that. VS squared equals VI squared plus 2 times A times delta y. I'll tell you what, instead of writing delta y, let's immediately substitute in YF minus y initial. Now let's rearrange it so we're solving only for YF. So what do I want to do first? I want to subtract VI from both sides. VF squared minus, VI squared. VI squared equals 2A times our YF minus YI. And then I want to divide both sides by 2A, right? So I'm going to come up here. VF squared minus VI squared divided by 2A equals YF minus YI. And since we're solving ultimately for YF, I'm going to add YI to both sides too. So here's our final equation here. VF squared minus VI squared over 2A, the quantity, plus y initial equals our y final. So I might need to cheat down here a little bit to punch all these in, or to write all these in. Our last equation, our last calculation, or really our only calculation, right? It's our last form of this equation right here. So let's punch our numbers in here. VF, what's our V final? Oh, it's easy. 0 squared minus VI, that's 30 meters per second. That value squared over 2 times negative 9.81 meters per second squared. All that plus, what's our initial position? 50 meters equals our y final. So multiply and divide all these together, add it to 50, and what's our final answer? YF equals 95.9 meters. Now that's what I got. I know the answer up here says 95.42. I think originally that was calculated only using an acceleration of negative 9.8 meters per second squared, and so that would, I think that would probably account for the discrepancy, but it should be 95 point something, probably closer to 96. Okay, so that's number 1, or sorry, that's number 2A. 2B, how long does it take to reach the peak? How long? That sounds like time, right? So change in time, that's what we don't know. Our initial velocity is 30 meters per second. Final velocity at the peak is 0 meters per second. Acceleration, still negative 9.81 meters per second squared. And we can write in our displacement, although we don't want to necessarily because that could be wrong. But I don't think we have to anyway, because I think we have an equation that relates time, initial velocity, final velocity, and acceleration. That's final velocity is initial velocity plus acceleration times time. Let's subtract VI from both sides and then divide by A minus VI. And then divide by the A. That should give us our time. So time is equal to, what's our final? 0 minus 30 meters per second over negative 9.81 meters per second squared. That'll give us an answer in seconds. And what we get is 3.06 seconds. 3.06 seconds to reach the peak. Okay, that's 2B. Let's go on to C.